Let's look at nomenclature now. So nomenclature is nothing but a systematic naming of chemicals so that everyone can understand what other chemists or scientists are talking about. For our course, there are only a few nomenclature compounds that we are going to look out for. And those will be alkanes primarily, and then alkenes and alkynes. We will also do a little bit of alkyl halides. Okay. Depending on how many carbons are in your molecule. For example, if there is only one carbon, the root word will be meth. For 2 carbons, it will be eth. For 3 carbons, it will be prop. For 4 carbons, it will be bute. For 5 carbons, it will be pent. And so on and so forth. We will have hex, sept, oct, non, and def. Now for our course, please make sure that you know how to name at least these 10 carbons. You should know how to name 10 carbons, up to 10 carbons. So when you're looking out for the name of any structure, the first thing that we look out for is the root name. What is the root name? A root name comprises of 3 things. There is a prefix, there is an infix, and there is a suffix. Within this, the prefix is the number of carbons. The infix indicates what kind of a hydrocarbon is there. If we have an alkane throughout, it will be an an. If we have an alkene, at least one double bond, we will label it with an en. If there is at least one triple bond, we will label it as a yn. And then in that root name, we will have a suffix. Suffix indicates the priority functional group in your structure. Generally, if there is no other priority, and the alkene, alkenes, alkynes, and the alkyl halides that we are going to look at, all of these 4 things, their root name always have the suffix of E. Now let's look at one of the examples. How many carbons do I have here? Anyone? 1, 2, 3, 4, 5, 6. Very good. So I have 6 carbons. What would be the root name of this compound will be? So how many carbons do I have? Very good. Hex. Throughout the molecule, I see alkanes. So I will put my infix, ane. And since it is an alkane, my priority will end with the E. And there should be no space. I wrote them a little away, but you should not have any space between these letters. All the alphabets should be without any space. Let's do another. Now this is not in your course, but I wanted to show this to you. Again, how many carbons are there? Still 6. So the prefix is hex. Still throughout, not considering the functional group, throughout there is a alkane. I will write the words an. But now my priority is not E anymore. Why? Because it's not an alkane, alkene or alkyne or an alkyl halide only. I have something different. There is a priority group on this. So instead of writing my E, I will write the priority OL. which indicates to me that in my molecule, I have a alcohol. So do you see how the E can change? And it will change when we will look at other functional groups, probably in our next course, when you go and do the organic 2. That is when you will be looking at alcohols and ethers and many other groups as well. But for now, just remember this: hex, ane, E. These are the 3 things that you have to imbibe in your root name. Now, this is a linear chain. If you have branched chain, let's say I have a branched chain right here. In a branched chain, you still have to find your longest chain. Longest chain as the parent chain. So parent chain is the longest chain. There are 2 things that you have to remember about the longest chain. First, the longest chain must have the priority. What does that mean? For alkanes, it is not a big deal. There is no other functional group in our alkanes. But in other molecules, when you will go about those, for example, you have a OH or you have a alkene or some other groups, please make sure that in your longest chain, you keep those structures intact, or you have counted or accounted for that double bond or triple bond in your longest chain. So that is the first rule that you have to remember. When you're looking out for parent chain, always look out for the longest chain, which must have the priority in it. And the second thing that you must do, and this is after you have figured out priority, is your longest chain must have most number of substituents. What does that mean for us? Let's say I have a structure like this. Okay. In this structure, the first structure that I had built, it is very easy for us. The longest chain will be 1, 2, 3, 4, 5, 6. Don't worry about the numbering yet. I'm just trying to we are just trying to figure out our longest chain for now. I can go with this, or I can go with 1, 2, 3, 4. Or I can go with 1, 2, 3, 4, 5. So among these 3 options that I might have in my longest chain, for my longest chain, which will be the best option? Definitely the one which is covering 6 carbons. Okay, not the 5 carbons, not the 4 carbon chain. It will be the 6 carbon chain. Now let's look at this particular molecule. Where will I have my longest chain here?
9.
Okay, very good, 9. But let's figure out how. Will I end 1, 2, 3, 4? That'll be too much. So if you look on this long chain, on the 3rd carbon here, I have replaced a hydrogen with a group, which we call as substituents, right? So these side chains or substituents are also important. But how are we going to name this side chain? It'll be long. Moreover, this is definitely not the longest chain. So let's look at 4, 5, 6. But do you think we can do better? 1, 2, 3, 4, 5, 6, 7. Let's try 1, 2, 3, 4, 5, 6, 7, 8. Let's try one more time. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And so there is no other competition. Let's try this one. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So definitely this is going to be our longest chain. Okay. So finding the longest chain, making sure that the priority is in the longest chain, and also making sure that more number of substituents are in that group, that is what our aim will be. Okay. Now before we proceed further, let's just look at this. This is our first rule. Okay, root name you have to imbibe, but the longest chain rule is also important. After the longest chain, then you look at locant value. What is the locant value? Locant value just indicates where your side chains or substituents are located. So on the chain, what is the location of that particular substituent? The only thing that you have to do with locant value is you have to make sure that this is smallest number for all substituents together. So let's go back to this. I can start my numbering 1, 2, 3, 4, 5, 6. Or I could start my numbering from this end. 1, 2, 3, 4, 5, 6. So if I follow my red marks, my locant for the substituent is 3. But if I follow my black mark, my locant for my substituent is 4. Which is the lower locant value? 3. So I will follow my red mark here. So what is the root name of the parent chain? It is still hex. Throughout it is an alkane, ane, no other priority, so I will end it with the E. But what is this substituent? How many carbons are in this substituent?
1.
Very good. What is the root name for one carbon?
Methyl.
Met. Yes. So it is met. It could have been a methane, but one hydrogen is missing. So when one hydrogen is missing, we call it as a met with a YL. So methyl. If I had 2 carbons, one of the carbons was missing the hydrogens, what would I call this group? Eth.
Acyl.
Because this is eth in E. This would be eth with a YL. So all the alkyl substituents, you have to count the number of carbons. Based on that, you will be giving their names. So you will indicate on your hexane what is the locant of your substituent. It is a 3. 3-methyl hexane. Yeah. This was a chain where I only had one substituent. What if I have a lot of substituents? When I will have a lot of substituents, like in this group, I have a methyl here, ethyl here, another ethyl here, another ethyl here. So I'm going to write ethyl and methyl. How would I know which substituent to write first? So remember, you have already figured out your smallest number for all the substituents. Now you will write your substituents of equal priority. So equal priority substituents are alphabetically written. Okay? And so, first of all, let's find our lowest locant. My lowest locant should be 1, 2, 3, 4, 5, 6. If I had started my counting from the opposite end, if I had started from 1, 2, 3, 4, my first locant would be at 4. 5, 6, 7. None of my substituents were on a 7 locant if I had followed this pencil marking. But if I follow my black ink marking, I have a substituent on 7. So I will never follow, I will not follow this route. I will follow the other route. So I have some methyls, I have some ethyls, and let's write the name of the structure. What is the first thing that I'm going to do? I'm going to write the parent name. There are 9 compounds, 9 carbons. So that would give me 9 carbons is non. Non. Throughout, there are alkanes. So I will write the word AN. No other priority. So it will end with the E. Now, on 4, 5, and 6, I have ethyls, while on 3, let me just write it here. On 3, I have a methyl, and on 4, 5, and 6,
Treble.
I have
Triacyl.
ethyl. Yes, Sammy, I will tell that. Thank you. Now, before we number our name, always remember that between a number and an alphabet, you have to give a hyphen. There is no space between any of the alphabets, but between a number and an alphabet, you have to give a hyphen. The other thing that you need to know when you're naming is that all the same groups, so for example, we have 3 ethyl groups here, all the same groups have to be named as di, tri, tetra, penta, and so on and so forth. Not alphabetically. What does that mean? It means that how many ethyl groups do I have here? 3. And as Sam indicated, 3 is tri. Now, usually if you see M comes before T, right? But we are not going to consider T. We are going to consider the E only. We are going to consider the M. So we are going to compare the M and the E. Any questions? What is this alphabetical writing? So I have all these substituents. I know that there are 3 ethyls. I will write all of their locations. Even if I have 2 ethyls on the same carbon, I will write them twice. So if I have 2 ethyls on the 4th group, I will write 4, 4, 6. So wherever your location of substituents are, you have to make sure that you write the number that many times and you tell how many of those substituents are right there. Then you have to make sure that you write all your substituents alphabetically. Are we considering the DT from the same number of groups? No, we are not. We're just focusing on the actual root of the word. So if you sing A, B, C, D, E comes before M. So I'm going to write 4, 5, 6. Now, just like your numbers and alphabets have a hyphen, all your numbers are separated by a comma. Again, no spaces are needed between them. 4, 5, 6. Number and alphabet will get a hyphen. 4, 5, 6 trimethyl. Next is 3. So I'm going to introduce another hyphen between alphabet and a number. 3 methyl, and the no name will come right here.
So that whole thing is just the name for that one structure?
Yes, yes. This, all of it is the name for this structure.
Okay.
And if two substituents are present on the same carbon, and that is going to happen a lot as well.
Wait, can you go back one more time? I'm sorry.
Yes, yes, please go ahead. Ramani. And if on the same 1, 2, 3, 4, 5, 6, 7, 8, if on the same carbon you have two substituents, make sure that you use that number twice. Now I'm going to introduce you to our alkyls also. So in IUPAC, halogen substituents are treated equally as alkyl substituents. So if there is a methyl group or if there is a halogen group, they are both equal. So there is no priority over one on the other. Armani, are you done with this?
Oh, yes, you can move it now. Thank you.
Oh, okay, thank you. So how I'm gonna name this? All of our halogens are just halo. Fluoro, chloro, bromo, iodine. Just like we have methyl, fluoro, right? So how I'm gonna name this structure? How many carbons are there? So I'm going to follow my rule. First, I will figure out my longest chain. Where is my longest chain? Definitely here. This methyl group will not be part of my longest chain. It will be the part of my substituent. So I have methyl and I have a fluoro. How many fluoros do I have? 2. So I'm definitely going to have a difluoro somewhere. So my longest chain must have priority. There's no priority. Both of these are similar priorities. Most number of substituents. There's not much choice that we have here. My locant value. Now this is where I have to count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I did my counting from this end. Let me count with this end also. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now looking at this, my locant value must be the smallest number for all the substituents. Where do you think I'm going to get it from? From the left-hand side or from the right-hand side? From the red or the black? From the black. Because if you look, my first substituent is on the 3rd location if I look from the black. And my first substituent will be on the 4th locant if I look from the red. So I will first give its root name. 9 carbons, non throughout hydrocarbon and no other priority E. I have a difluoro. Where do I have a difluoro? It is on the third and the
6.
sixth location. Yes. So 3, 6 hyphen difluoro. Where is my methyl? It is on the
6.
sixth also. So I'm going to label that number again. Who is going to be written first? The D or the M or the F?
F.
The F. We are going to consider F first. So 3, 6 difluoro hyphen 6 methyl nonene. Okay. Now there might be a problem when you have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. When you have equal locations. 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. Counting from either side, our first substituent is on the second location. Counting from this, my first substituent is on second location. Where is my second locant going to be? It is going to be on the sixth. So in both these cases, I'm going to have 2, 6 kind of locants, either from the black or from the red. So this is a tie. In case of a tie, so this is C here. In case of tie, and I'm going to write the rest here, of same locant value. If your locant value is same, then you give alphabet priority. Give priority 80. So imbibing this rule in here, what comes first? The chloro or the fluoro?
Chloro.
I'm sorry, the chloro, yes.
Chloro.
So I will not look at this numbering. I will now look at this numbering. But this I did only in case of tie. If I had a molecule like this, where 1, 2, 3, 4, 5, 6, 7, 8, or 1, 2, 3, I would not go with this numbering where my first locant is at 3. I will go with the numbering where my first locant is at 2. So this is a heptane, 2 chloro, and 6 fluoro.
Chloro.
And no
No,
space
6.
between. Yeah,
No.
6 fluoro. What?
Just a second. Chloro.
No, not for this. For this one.
Yes, okay.
So the alphabet got the priority here. Okay. So our class time is now over. It is 2:30 now. We will be looking at the branched nomenclature tomorrow, and please make sure that you revise your acid bases and resonances for tomorrow's drill test also. Okay, anyway, let's just stop for today.